Have you ever been scrolling through TikTok and just wondered, how does this work? I mean, how does an app that big with that much content feel so seamless? Well, today we are going right under the hood to break down the incredible engineering that powers this global phenomenon. When you're just scrolling, it really does feel like magic, but it's not. It is an absolute masterpiece of system design. So that's the big question we're going to answer today. How on earth does an app like this serve billions of videos every single day without, just completely breaking a sweat? All right, here's how we're going to break it all down. First, we'll look at the just insane scale of the problem. Then we'll check out the blueprint they use to build for that scale. We'll follow a video's journey from the moment it's uploaded, see where it lives in this giant digital library, and then figure out how it gets to your phones so fast. Finally, we'll wrap up with the big engineering lessons. Okay, so first things first, the billion view challenge. I mean, we're talking about engineering for a mind-boggling scale. When you're building a system that hundreds of millions of people use every day, you can't just wing it. You have to plan for unbelievable amounts of traffic from day one. The stakes are huge. And to really get a sense of that scale, just look at this comparison. On any given day, you might have, say, 100,000 people creating and uploading videos, but you've got 10 million people watching them. This massive, massive imbalance between who's creating and who's consuming, that right there is the key to everything. So, knowing that, where do the engineers even begin? Well, before you can write a single line of code, you need a blueprint. And for an app like this, the entire blueprint is built around one single crucial number, a number that honestly changes everything. And here it is, 100 to 1. That is the magic ratio. On average, for every one time a video gets uploaded, it gets viewed 100 times. Seems simple, right? But this little ratio completely dictates the entire architecture of the system. So what does that mean in practice? It means the whole system, the entire thing, has to be overwhelmingly optimized for fast, reliable video delivery, what engineers call reads, rather than handling the uploads, which they call writes. Getting that video to you, the viewer, has to be 100 times more important than taking in the new video from the creator. So with that one big idea in mind, the engineers can set some ground rules. The system absolutely must be on 24/7. That's high availability. It has to feel instant when you're scrolling. That's low latency. It needs to be tough, so if one piece of it breaks, nobody even notices. That's fault tolerance. And finally, it's okay if a new video takes a few seconds to show up for everyone around the world. That's called eventual consistency, and it's a trade-off they're willing to make. All right, so we've got the rules. Now let's follow a video on its journey, starting right at the beginning in what we can call the video upload factory. This is all about what happens the exact moment a creator hits that upload button. The second you hit upload, your phone sends that video file over. But, and this is important, the system doesn't start working on it right away. Instead, it gets placed into a queue. Think of it like a digital waiting line. This is a super clever way to stop the system from getting totally overwhelmed when everyone's trying to upload at once. Only after it's waited its turn does the real heavy lifting begin. And this really illustrates a brilliant engineering principle. This quote says it all. What you have done is you have decoupled ingestion rate from processing rate. In plain English, it means the system can take in a flood of new videos without slowing down because all the hard work of processing them is happening separately, in the background, at its own steady pace. It's genius. So what is all that heavy processing I mentioned? Well, it's something called transcoding. Your single video file is actually turned into a whole bunch of different versions. We're talking different resolutions for fast or slow internet and different formats for iPhones versus Androids. And to make it super fast, this all happens at the same time, in parallel. It's all to make sure that no matter what device you're on, that video plays perfectly. Okay, so now we have like a dozen different copies of every single video. Where do they all go? Where do they live? Well, that brings us to the system's massive global digital library. And it's not just one giant hard drive. Smart engineers use the right tool for the right job. So the huge video files themselves, they go into something called object storage, like Amazon S3, which is perfect for big, clunky files. Then you have the video's metadata, the title, hashtags, stuff like that. That goes into a super flexible NoSQL database. And finally, all your user data, your profile, who you follow, that lives in a classic, super organized SQL database to keep it all neat and tidy. But look, just storing the videos, even in the right places, isn't enough when you've got a global audience. That's where this thing called a CDN, or Content Delivery Network, comes in. And the analogy here is perfect. Think of it like a worldwide network of local libraries, but instead of books, they're storing copies of videos, keeping them physically close to you so they can be delivered way, way faster. And that CDN is the final piece of the puzzle. It's the secret sauce, the real magic behind that endless, instantaneous scroll that we all know. How does that video get from the library to your screen in a split second? It's actually pretty simple in concept. When you open the app, your phone doesn't have to reach out to a server halfway across the planet. Nope. It just sends a little ping to the nearest CDN server, maybe just a few miles away. That server instantly sees what kind of phone you have, how good your connection is, and immediately starts streaming the perfect version of the video right to you. That's why it feels so fast. So let's zoom out and wrap all this up. What are the big lessons here? These are the core principles that make it possible to engineer these massive internet-scale apps that we all use every day. All right, here are the big takeaways. First, always separate your uploads from your processing using queues. Second, make copies of everything and spread them out so the system never goes down. Third, use the right database for the right kind of data. Don't try to force it. When you have a really big job like converting a video, break it up and do all the pieces at once. And finally, get your content as close to your users as possible with a CDN. And that really just leaves us with one final thought to chew on. As technology keeps changing, which one of these principles, which of these big ideas do you think is going to be the most critical for building the next app that reaches 1 billion people?